Welcome to Chapter 2.2, Adding Fractions. Now many of you may recall how to add fractions from your previous math courses, so I'm going to start off with a basic addition question here. So here what we have is we have 1/8 plus 5/8 plus 3/8 plus 2/8 plus 1/8. So based on your previous knowledge, add these fractions together. So now would be a good time to take a quick pause. Alright, so our answer is 12/8, which then reduces to 3/2. So how do you actually go and solve this problem? Well, if we generalize here, what you actually did in order to solve this question was you added the numerators together, but the denominator stays the same. And of course, in this case, we were able to reduce the fraction, so we did just that. So hopefully this reminds you of some of the techniques that you've worked with before in your previous math courses. So in that previous question, you were able to add the numerators because the denominators happen to be the same. Now what happens if the denominators are different? Well, then you first need to find what we call the lowest common denominator, otherwise known as the LCD for short. So what I've got set up here is 4 pairs of fractions, and your job is to look for the LCD in each of these pairs of fractions. So now would be a good time to quickly pause and see if you can find the LCD for each of these pairs of fractions. Okay, so in question A we have 1/4 and 2/5. The LCD, the lowest common denominator, is 20. In B, 7/2 and 5/3, the LCD is 6. So if you recall how to find the LCD, one simple way is you take the two denominators, 4 and the 5 in question A here, multiply them together and you get 20. In question B, 2 and the 3 are the denominators, so you multiply them together and you get 6. Now this doesn't always work, but it's a good starting point to help you find out what the LCD is. If we applied the same technique to question C, 7 and an 8, we get an LCD of 56. And in the final question D, we have 5/6 and 6, which is really 6/1. So therefore the LCD is 6. Okay, so once you've found the LCD between the fractions, the next thing you want to do is write what we call an equivalent fraction that has the LCD in it. Finally, you add the numerators together, just like we did previously. Denominators stay the same, and of course you always reduce if that is possible. So here I have 4 questions set up for you to add up the pairs of fractions. So now once again is a good time for you to pause, try these questions first, and then check your answers. Don't forget to write your equivalent fractions in between, okay, before you simplify and reduce. So for 1/4 and 2/5, we already took a look at these two fractions, and the LCD was 20. So we need to think to ourselves, well, if we want an LCD of 20, what do we need to multiply by? Well, we multiplied the 4 by a 5 in order to get an LCD of 20. So therefore we need to multiply its numerator by 5 as well. And therefore we get an LCD, a numerator of 5. In the second fraction, we multiplied the denominator by 4, so we need to multiply the numerator by 4 as well, and therefore we get a numerator of 8. So we simply now add the two numerators, 5 and 8, gives us 13. The denominator stays the same at 20, and this one doesn't reduce, so therefore 13 over 20 is our final answer. In question B, the LCD is 6, so we multiplied the 2 by a 3, so therefore we multiply the numerator by 3, and therefore we get a numerator of 21. In the second fraction, we multiplied the denominator by 2, so therefore we multiply its numerator by 2. So we get a numerator of 10. So 21 over 6 plus 10 over 6, those are what we call the equivalent fractions. You add the numerators together now, we get 31. The denominator stays at 6. This one doesn't reduce, so therefore that's our final answer. In question C, our common denominators are 56. And I'm just going to click through these a little quicker. 24 and 21 become our numerators. Add those together, we get 45 over 56. In question D, 6 is our lowest common denominator. So the first fraction already has the common denominator of 6, so its numerator stays as 5. Whereas the other one, 6, becomes 36 over 6. So when we add our numerators together, we get 41. Denominator is 6. Alright, so we ramp it up to the next notch. In question A here, you'll notice the first fraction is written as a mixed number. So in order to add fractions that have mixed numbers, you first of all should convert into an improper fraction first. So you may recall that to convert a mixed number into an improper fraction, you need to multiply the denominator of the fraction, multiply that to the whole number up front. So in this case, 4 by 4 gives you 16. Then you need to add the numerator. So we've got 16 plus 1. That brings us to 17. And the denominator remains the same at 4. So it would be 17 over 4. You would write the other fraction out again. So it's 4 over 9. So now that we notice that both denominators are different, we need to look for an LCD. In this case, the LCD would be 4 times 9, which is 36. So the equivalent fractions will be 153 over 36 and 16 over 36. Numbers get a bit large here, so you're welcome to use a calculator. When we add up the numerators, we get 169 over 36. Doesn't reduce, so that's our final answer. Now in question B, we have 3 fractions, and all 3 fractions have different denominators. So we need to look for an LCD that is shared between all 3 of the fractions. So between a 3, 4, and a 2, the lowest common denominator would be 12. So we need to write the common denominator as 12 and write the equivalent fractions for each of these original fractions. So we've got 8 over 12 plus 9 over 12 plus 30 over 12. And then of course, just like we did before, we add the numerators together. The denominator stays the same. So we get 47 over 12, which doesn't reduce. So there's our final answer. Alright, and finally, here's an example of a word problem that you might see in your textbook and perhaps on your tests later on. Here it says art students are trying to complete a survey of their favorite activity. Ceramics is the favorite of 2/5 of the students. Drawing is the favorite of 3/8 of the students. So it's asking what fraction of the students chose either ceramics or drawing as their favorite activity. So this is simply just an addition question. You're simply going to add the two fractions of students. So we're going to set this up first of all by writing out an equation for ourselves. So 2/5 plus 3/8. Now in this situation, the denominators are different, so we need to find an LCD. In this case, 5 times 8 is 40. So that will be our LCD. So we multiplied 5 by 8. So we'll multiply its numerator by 8. So the equivalent fraction will be 16/40. The second fraction we multiply by 5. So we multiply its numerator by 5. So the equivalent fraction will be 15. So now we simply add the numerators. 16 and 15 gives you 31. Denominator stays the same at 40. So our answer should be 31/40. So we'll check our answer using this handy dandy magnifying glass. And there you have it. 31/40 is our final answer. So hopefully these examples have helped you recall how to add fractions. Any problems or questions, then feel free to ask in class.